what is the noise you just heard? This is a standing wave in an air column. In an open tube, the FFT would look like harmonics at every integer, so 1, 2, 3, and 4. With an open closed system, the tube will be capped at one end and it creates a different pitch. The harmonics would be at every odd integer instead. What the waves look like, here's the math.
Here's the math, okay. Since these are two different systems, we got open, closed. The formulas are different, okay? So when you're trying to find the wavelength for the open, it's the wavelength of an integer, so we could say 1, and that's 2 times the length of the tube divided by 1. But when you're trying to find the frequency, it's the frequency, to find the fundamental, it's the frequency equals the velocity, so the speed of sound in the air.
And what is that, Garrett?
The speed of sound in air, like I just said.
The number.
340 meters per second, divided by 2 times the length. Now if you're trying to find like the second harmonic, it's going to be 2 times the fundamental. Now, in an open-closed system, it's quite different. It's the wavelength of an integer, so 1 equals 4 times the length divided by that integer, or 1. And we're trying to find the frequency of the fundamental. It's the same thing, but replace the 2 with the 4. So velocity, 340 meters per second, divided by 4 times the length. And then, this is where it gets tricky. Open-closed systems cannot have a harmonic at even integers, because science won't allow it. So, to find the next harmonic up, it's the third. So 3 times the fundamental. It's crazy. That's all I can
Change is length versus wavelength. If you change the length of the tube, the wavelength will change. And if you keep the length of the tube where it was, and you change the wavelength, you see the reflections move and you get distorted footballs. The animations you see at the top, the first picture is a longitudinal wave, and where the red dots are, if you can see them, are nodes. And everywhere else where the particles scrunch together, those are antinodes. And since that picture is super confusing, you can look down to the second and third picture, and they show what's happening. Obviously on the line down the middle, where nothing is happening, that's a node. And where the line is wiggling and creating footballs, that is an antinode.
Okay, so now we gotta look at the differences with the tubes. They're all different ones. Okay, so how does this affect the properties? Longer tubes have a lower pitch. Shorter tubes have a higher pitch. Now why is that? So, when the wavelength is decreased, by shortening the tube, the frequency is increased. And the
Could you
opposite.
demonstrate that with the long tube and the short tube?
Crazy. Science. Okay. And the opposite happens when you increase the length of the tube, the frequency goes down. So, in this order here, we have the D, the E, the B, and the C. So the decrease in length and wavelength, increase in frequency.
Oh.